Hello. I thought I would do another puzzle. I was just on this Logic Masters Deutschland site that I really liked, and they've got a list of recent puzzles. I think people post puzzles when they come out. And what had happened was, I went to the newest video at that time. If I can get this to work at all, which I guess I can't. But it's loading the page. There was a recent puzzle called Sudoku Speedrun. I thought it'd be kind of like a nice morning puzzle to do. It was 1 star. I didn't think it would be as easy as it was. The whole puzzle was a speedrun. It only took about 30 seconds. It's a 4x4. Naturally, then, I said, well, maybe I should record, maybe I should do a harder puzzle if I'm trying to get my brain active in the morning. And I then saw that Dutch Flatmate's X Sums came out today. So I've played through a lot of the Dutch Flatmate puzzles. I believe it's a weekly series by Flinty, where the author is mixing this Dutch Flatmate rule that is kind of fun and interesting with some of the other rules. But I thought I would do the one that came out today. I've done a lot of these Dutch Flatmate puzzles, so I'm pretty well versed on that rule. I'm not super well versed on the X Sum rule. I'm going to have to read that and figure out what it is. But I think this will be fun. This is a brand new puzzle. It's only 9 hours old, and it has a solve counter of 94. So maybe I can make myself the 95th solver, or maybe there's a bunch of people playing it now, and I'm going to be the 150th solver, and I'll figure that out here in a little bit. But this is the puzzle. Dutch Flatmates, X Sums by Flinty. What are the rules? So, normal Sudoku rules apply. 5s live in Dutch flats. All 5s in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. This is good. I always sort of stumble over reading this rule because previously, or in some other puzzles, it's been written as strictly either or. But this is good. When we have a 5 in the puzzle, the 5 is Dutch. That means that I'm either going to need to place a 9 below it or a 1 above it, or I could put both. It doesn't need both, though. That's the Dutch Flatmate rule. What is the X Sum rule? Clues outside of the grid are the sum of the first X cells in the corresponding row or column, where X is the digit in the cell nearest to the clue. So I believe what that means is that if this is a 12, for example, and we were somehow able to identify the fact that this cell here was a 3, what we would need is the first 3 numbers in this row to sum to 12. So how would we do that just in this example case? Well, that would mean that these sum to 9, so maybe I could do 5 and 4. And then maybe we would need to apply the Dutch Flatmate rule, so we would need maybe a 9 below the 5 or something like that. Maybe that's what we would need to do. But it's been fun playing through this series. I've done a bunch of them. The author, finds new rules to mix this Dutch Flatmate rule with. And this is I'm much better versed with the Dutch Flatmate rule because of it than I am with the X Sum rule. So I'm going to have to learn a little bit about that rule to be able to play this puzzle, I think. But my inkling is to start with the high and the low X Sums. The lowest by far is this 7. I know that if you want to make 7 with 3 numbers, then you need to use the numbers 1, 2, and 4. But that seems to cause a contradiction in this case. I see. I think I know. It's pretty early. We're only 2.5 minutes into the puzzle, but I think I know how we can whittle down the cases here. We could think about what needs to go in the blank. Is it possible to have a 1 in the blank here, the X? Is it possible to have 1 as the X? Well, no, because then the sum would need to be 1. Or rather, we would take the sum of the first number and we would get 1. That doesn't work. Is it possible to have a 4 in the blank here? I don't think it is, because we would need to take the sum of the first 4 numbers and get 7. And 4 is just a little too big. If we were to add the smallest 4 numbers on the number pad, we would get 10. So I don't think this can be a 4. But I think we also just showed it can't be 3. It's possible to make 7 as the sum of 3 numbers. It is possible. We could use 1, 2, and 4. but that sum doesn't contain a 3. If this was a 3, these two numbers would need to sum to be 4. The only way of doing that is 2 and 2, which would cause a contradiction, or 3 and 1, and that would cause a contradiction also. So I think what that means is that it needs to be the sum of the first two numbers. I think this needs to be a 2. And then because of that, the first two numbers need to sum to 7. This needs to be a 5. Yeah. Okay. That was a fast little piece of progress for the beginning. That's a low number. Should I look at the other low numbers? I'm sort of inclined now to think about this 17, which intersects the 5. But maybe there's just multiple pieces of progress that I'm supposed to make at the beginning too. So this is a 9 because of the fact, I think, first of all, I don't think any of the x sum numbers, I don't think this, or this could be 1, for example, because of the fact that we can't add like a 1 and make 17. If we had a 1 outside of the grid, that would be possible. But I think the minimum number that we could really have in these is 2. But we just showed that if this was a 4, I would need to sum the first 4 numbers to get 9. And the sum of the smallest 4 numbers is 10, so a 4 isn't allowed. I think what that means is that you guys, you need to be a 2 and a 3 in some order. And maybe we could figure out what happens in each case. So if this is a 2, then the sum of the first 2 numbers needs to be 9. That would make this a 7. So maybe this is a 7. This is a 2, then this would need to be a 7. This is a 3. I think things become a little more complicated. I assume we would need the sum of the first 3 numbers to be 9. Maybe I should have said that a 7 needs to go in one of these two. That's fine. 7 needs to go in one of these two cells. But if this was a 3, then we would need to make 9 here. But this is definitely a 3. That means that the sum of these two numbers would need to be 6. So we need to add to 6 with 2 numbers. But we aren't allowed to use 3, and we aren't allowed to use 2. I think what that means is that the remaining numbers there are going to need to be 5 and 1. I think whichever of these is a 2, it's going to put a 7 here. The other one is going to be a 3, and that's going to have a 5 and 1. So I think what it's going to look like is something like this. 5 and 1. And now we have 3 numbers that definitely go in 4 squares. It'd be nice if I could put a 4th number in, but I'm not sure we can do that. This can't be a 1 because of what we said before. We can't have a 1 closest to that. We can't have a 1 as the x in the x sum. You can't be a 1. If you can't be a 1, then I guess you can't be a 5. But it's still possible to have 3, 3, 1, 5. Now, because of the Dutch flatmate rule, I would need to put a 9 here. But that might be allowed because then I would put 7 and 2 here. So maybe this is where we are now. There's an extra number somewhere in this. And that extra number definitely goes... I think it definitely goes in one of these two. I think. Yeah, that extra number definitely goes in one of these two. This can only be 1 or 7. And this can only be 1, 5, or 7. But there's an extra number. I do want to get down here and think about this 17, because 17 seems like a reasonably small sum. I'm not sure. Be interesting if we could put some restrictions on this, but this is also very interesting. It does look like there are 2 different combinations that work. Regardless, I'm going to know that one of these is of length 3 and sums to 9, and now I could think about the fact that there's going to be a 20 facing it. The sum of the digits in the full row, that's 45. Sum of the digits in this row is 45 also. Which means that there's sort of like a cage that's in the middle. We don't know where it goes, but there's going to be a gap where the numbers add to 16 for both of these. For both of these. I am 9 minutes into the puzzle, and I have gotten 2 numbers and some pencil marks, but more progress must be made. I could think about the Dutch flatmate rule. For example, if this was a 5 and it's against the ceiling, we would need to place a 9 below the 5. That seems like it's allowed. If this was a 3, it really fills itself all the way in. If this is a 3, then this needs to be a 1, this needs to be a 5, and this needs to be a 9. This needs to be a 7, and this needs to be a 2. If this is a 2, then this is a 7. We don't know what this is, and we don't know what these are. We know that this is a 3. I wonder how to add to 20. Sometimes when I do puzzles, I focus on the wrong thing at the beginning. And I'm worried that this was the thing, the 17 is what I'm supposed to focus on, but maybe I should focus on these 20s just for a moment because we're up here. There's some number, maybe this is a 4. That would mean that these 4 numbers sum to be 20. And maybe this is a 2. That would mean these numbers sum to 9. That means that there's this middle pocket of 3 that are going to sum to 16. It might be possible to rule out that one case because of this. It might be possible to place all of these numbers. See, there's a case, and I want to rule it out. That case is, if this is a 3, that's a bit unfortunate. You know, when you put a 3 in the corner in the Sudoku pad, confetti pops out. I love the confetti, but that seems like I didn't deserve it because I'm just trying to fill in some numbers to think about it. This is the possibility, this is what the numbers would need to look like if the 3 went in the corner. And that was deserved confetti. This was deserved confetti. The 3 would need to go in the corner. I would need a 9 here, a 7, a 2. These would need to add to 18. I would need to make 20 over here somehow. And then the numbers in the middle would need to sum to 16. The thing about that, though, is that there's only one way to sum to 16 with 2 numbers. There's no way of summing to 16 with 1 number, which means the gap in between where this one... Oh, this is part of the gap. So I could make the 16 by doing 9 and 7. That wouldn't really work. I would need to make the sum of these 3 numbers 16. So U2 would need to add to 7. I would not be allowed to use 2 and 5 to sum to 7. I would need to use 6 and 1 or 4 and 3. But I couldn't use 4 and 3. I would need 6 and 1. I couldn't use 4 and 3 because then this would need to be a 4. I'm sort of playing through one case because I want to rule it out, but I also just want to think about the X sum rule and how it works because I don't know if I've really successfully completed a puzzle with the X sums and very little other information. I'm going after the case here. I want to rule this out where these 3 numbers sum to be 16. It would need to be these 3 numbers would sum to 16. It wouldn't be possible for these 4 numbers to sum to 16 because of the fact that these would then need to sum to 7 and I would need a 2. So it needs to be these. 3. These need to add to 7. I need a 4 here. Means that this needs to be 6 and 1. This would need to be 6 and 1. But now things I think would work. I think if I just fill in anything here, this is like an extended sort of 5 and 3. Yeah. This is a way of making everything work out when the 3 is in the corner. I was hopeful for the fact that things would not work out, but I think they do. I could think about putting the 2 in the corner and play the same thing through. There's only 2 options really for what can go up here. If this was a 2, we could play it out and think about it. This would need to be 3, which means these would need to be 5 and 1. I would need a 3 here. So these numbers sum to 9. Now I need to split this into a sum that sums to 20 and a sum... In both cases, this seems to need to be a 4, doesn't it? Could it be a 5? If this was a 5, then this number would need to be 16. I think that's right. I think that's right. I think this needs to be, I think this number here needs to be a 4 in either situation. Why is this? Because I can't sum to 20 with 2 numbers. There's already a 3 in this row. So I couldn't sum to 20 in this case with 3 numbers. If I tried to sum to 20 with 5 numbers, this number would need to be 16. You need to be a 4. In any situation, you need to be a 4. I should have maybe thought about what the possibilities are for summing to 20. I need at least 3 numbers to sum to 20. But I think I can have at most 5 numbers that sum to 20. That means that these need to be a 3 and a 5. Maybe I am going to get a 3 in the corner. I think I definitely... I suppose it's possible to not have a 3 in the corner. Felt a little bad about that early confetti where I was filling in numbers and thinking, but I think it's true. I think you need to be like this. Now, wherever the 3 is, the other 2 numbers need to sum to 17, and there's only one way of doing 17. It's 8 and a 9. So it's possible. So U2 could be an 8 and a 9. U2 could be an 8 and a 9. If it's 5 numbers that sum to 20, and they contain a 5, then the 4 numbers after it would sum to 15. This is a very challenging puzzle, but it's also a very challenging rule. I haven't played much with the XSum rule. I think we know for certain that this needs to be a 4. If this can only be a 3 or a 5, and this 3 places a 5 here, then I don't think this can be a 3. I think this needs to be a 2. Excuse me. You need to be a 2. You need to be a 7. Now you need to be a 3. And it's a little bit up in the air what the rest of you are, but I think it needs to look like this. And now maybe it's possible to place these numbers because we're not allowed to use a 3. We need to sum to 16 in these 3 numbers. We're not allowed to use a 3, a 1, a 5, or a 4. I have an inkling. What would we need here? A 2, a 6, and an 8, I think, are the only ways of doing it. I think we need a... No, we could have a 1... No, there's many ways of doing it. Oh, I can't use a 1. I think you need to be the numbers 2, 6, and 8. I think that's the only way of doing it. And now you need to be... You're certainly the numbers 9, 1, 2, 3, 9, 4, and 7. Interesting. Maybe what I should do is I should make this. I'll continue with the corner pencil marks. But I think this is what we've figured out. So actually, I feel pretty good about where we are now. 20 minutes in, we sort of have this whole row together. So what's going to go on is that these four numbers are going to be the numbers 2, 4, 6, and 8. 2 and 8 make 10, 6 and 4 makes 10, we get 20. This is the interim set. They sum to 16, and then this sums to 9. These three numbers sum to 9. These two numbers are going to sum to 9. I can now figure out what goes out here. These numbers, we're not allowed to use 1, 2, 3, 5, or 7. I need to use the numbers, what? I need to use the numbers 4, 6, 8, and 9. It's not possible to put a 9 here. Actually, I may have even said this earlier. I'm not quite sure. Because of the Dutch 5 rule, if the 5 is next to a 1, we need a 9 below it. That means the 9 can actually only go here. You're not allowed to be a 9. You're not allowed to be a 9. One of you must be a 9. Adding a lot of pencil marks. A lot of pencil marks. I don't know if it's possible for 8 numbers. This may now need to be a 4. Because we need to sum to 20. If I was to use 6, if this was a 6, I would need 6 numbers that sum to 20. The minimum possible sum for the first 6 numbers is 21. That's not possible. You need to be a 4. You need to be a 4. And now, maybe I can remove this, because I think I can see what's going on down here. But the first 4 numbers need to sum to 20. What does that mean that you can be? If you were 4 and 1, we have very little information about the cell. If you think about it, I guess it's seen by this x sum, but it's not seen by another x sum or anything like that. It's in a region where we have no numbers, and the only number pointing at it is 4. I think we have very little clarity about this, but if this is a 4, these numbers need to sum to be 16. If this was a 5, then we would need a 9 below it. That would sum to 14, and this would need to be a 2. You would need to be a 2. If this was a 1, then these two numbers would need to sum to be 15. I could use any of these options, which would mean this could be a 9, a 7, or a 6. Interesting. I need a 7 somewhere in this row. It's not possible to appear here. It's also not possible to appear here because of the 7's there, so one of you two must be a 7. One of you two must be a 7. We should notate that the correct way. One of you two must be a 7. But maybe that's all we have at this point. Maybe I can think about what happens if this is like a 3. If this is a 3, then these two numbers need to sum to be 17. That would be 9 and 8. Actually, now that I think about it, whichever one of these is a 3 needs to be followed by 7 and 8, or 9 and 8. So if you're a 3, then you're 9 and 8. If you're a 3, then you're 9 and 8. But you two must contain a 7, which means you must be a 3. And now we get confetti that we deserve. This must be a 3. This must be 9 and 8. You must be a 5. And that is difficult because you're going to have a 7 with you. Say it's this one. Say it's either of them. Well, what goes we need a situation in which these 5 numbers sum to 20. That's pretty restrictive, I think. These 4 numbers need to sum to 15. If you take the 7 out of the equation, then the remaining numbers need to sum to 8. We have 3 numbers that sum to 8. We're We're not allowed to use 5 in that, so we can't do 8 with 5, 2, and 1. 3 numbers that sum to 8 that don't contain a 5 means it also can't contain a 6. We need numbers that sum to 8 that don't use 5 and 6. We would need 1, 4, and 3. So you two can contain a 7. One of you must contain a 7, actually. But the other numbers I think that we're allowed are 1, 4, and 3. But you're not allowed to have 4 and 3 in you. You need to be 1 and 7. You need to be 4 and 3. And then let's check our math and make sure that that all worked out. You need to be 1 and 7. So what's happening here, the sum of these numbers needs to be 20. This is 5. This is 8. And this is 7. I think that does it. I think that's right. We have a 5. The 5 has something above it. This is a Dutch neighbor 5. It needs to have a 9 below it. And now this is a 5 that needs a Dutch neighbor, but it wouldn't be allowed to have a 9 below it. It needs a 1 above it. That means this needs to be a 7. This needs to be a 1. Now you're not allowed to be a 9. And I should think about what happens when you're not allowed to be a 9. When you're not allowed to be a 9, what situation is this? This is the 4-1 situation. If we have a 4 and a 1, then these two numbers sum to 5 means these numbers sum to be 15. How can we do that? Why was it ever possible for, the 4-1 situation? If this is a 4 and 5, then we can have 9 and 2. That works. But if this is a 4 and 1, then these numbers need to sum to be 15. I don't think it's possible for you to be a 6 anymore. I think you need to be 9 or 8. You need to be 6 or 8. You need to be 6, 8, or 9. Is there a number missing in this row? There is. It's the number 2. A 2 needs to go somewhere in this row. It needs to go here. Now you're not allowed to be a 2. So one of you two must be a 2. One of you two must be a 7. Interesting. I can still have 4, 5, 9, and 2, though. That's possible. That is possible. I've used up a lot of our x sums here. Should I fill in what these numbers need to be? In this row, we're still missing the following. We're still missing a 1. And that's a good place to start because the 1 can't go either here or here because of the x sums. You need to be a 1. And now, the numbers that I'm missing in this row are 5 and 6. It's not possible to put a 6 here and add to 20. We know why that is. You need to be a 5. And now you need to be a 6. You need to be a 6, actually. Because of the Dutch neighbor rule, this 5 needs a Dutch neighbor below it. And the lower neighbor is always a 9. You now need to be a 7. You now need to be an 8. You need to be the numbers 2 and 6. You need to be the numbers 2 and 6. Whole bunch of progress. We can figure out 20. 20 has to be made by the sum of the first 5 numbers. But this here sums to be 14. That means these 3 numbers need to sum to be 6. There's only one way of doing 6. It's 3, 2, and 1. There's a 1 here, a 2 here. This can be a 3. So you need to be a 3, you need to be a 1, you need to be a 2, and you need to be a 4. And now you're not allowed to be a 2. And the thing is that if you're not allowed to be a 2, then you two need to sum to be 15, which means you need to be a 1. You need to be a 5, and now you need a Dutch neighbor. You're going to need a 9 below you. Now you need to be an 8, and you need to be a 7, and you need to be a 6. This is a crazy puzzle. I totally haven't done the x sums like this before. This is an interesting one. Tons of progress coming down from the top. Wow. Almost a worrisome amount of progress. What's next? I think that we've filled up the following exomes. We filled, maybe I should even mark to myself which ones we filled and which ones we haven't. I mean, we filled all of these. The one that we haven't filled is this 35. U6 numbers need to sum to be 35. U2, U3 actually, you sum to 15. That means you need to sum to 20, and your three numbers that sum to 20. Three numbers that sum to 20 and don't have 6 and 7. That seems difficult. So what could I do? I need to sum to 20. Say there was a 9 in this region. That means the remaining two numbers, and that's not even allowed here, but say there was a 9 in this region and I needed to sum to 20. The remaining two numbers would need to sum to be, excuse me, if there was a 9 in these three cells need to sum to 20. The remaining two numbers would need to sum to be 11. I can't use 5 and 6 because there's a 6 in the column. I can't use 4 and 7 because there's a 7 in the column. I can't use, oh, I can use 8 and 3. 8 and 3 is a possibility. I think that is the only way of doing this when there is a 9 in the region. The question is, what happens if there is not a 9 in the region? Is there another way of doing this with 8? There is. I could use 8. No, there's not. There's not. I'm thinking about taking the 9 and reducing it by 2. I would get 7. What I would need to do is reduce the 9 by 4 to avoid this 6, 7 thing. I would need to make this 9 into a 5, and then that 3 would become a 7. I think these are the only three numbers that can go here. And we know that the 9 can't go here. Now I want to apply some Dutch flatmate logic. Where does the 5 need to go? There needs to be a 9 in one of these two cells. That means it's not possible for the 5 to go here. We would need a 9 below it. That would cause a conflict. It's not possible for a 5 to go here because of the 5 in the row. It would be possible to put a 5 in either of these two. It's not possible to put a 5 here. Our 5 must go here. And if our 5 goes here, it needs a Dutch neighbor. It needs a 9 below it. And now what are the remaining numbers that go in here? We know where the 1, 2, 3, 5, 8, and 9 go. We're missing 4. We know where the 4 goes now. 6 and 7. Those are the numbers that we're missing. You need to be a 6, you need to be a 7, and you need to be a 4. This is a crazy puzzle. Or it's a crazy rule, and I just haven't played. I'm going to have to go find more exomes puzzles. I've really played very, very few. But it's been fun to think about. Wow. Please. I wish I could do something that would resolve what these are. Now maybe I start building up. I'm not quite sure. I wish I could do something where I say, well, a 4 certainly needs to go here or here, because there's a 4 in this row, and there needs to be a 4 in this region. So that remaining 4 needs to go in one of these two. Dang. Now I could think about the fact that a 4 needs to go here. I wonder if I should think about this. This one. I'm noticing something else, which is that I still need Dutch neighbors. I mean, there needs to be a 5 somewhere in this column, and that 5 is going to need a 9 below it. There needs to be a 5 somewhere in this column, and that 5 is going to need a 9 below it. Yeah, it's possible to make this 5 and 9. It's possible to make this 5 and 9. A 5 needs to go here. But I could think about that. Like, if this is a 5 and this is a 9, these two numbers sum to be 14. This would need to be a 3. But that would all work out. It's not possible to make this a 5, because then this would need to be a 9. And the sum of all 9 numbers, because of the x sum, would need to be 17. So you need to be a 5, you need to be a 9, and now you need to be a 3. This is mayhem. You need to be an 8. You need to be a 9. We've added to 17 here. But I need to add to 17 in a whole different way. I have a feeling it's not possible to put a 5 here for 2 reasons. 1, there's a 5 in the region already, but 3 reasons. 2, there's a 5 in the column already, but 3, if I was to take the sum of the smallest 5 numbers, I would get 15. Okay, so maybe it's not possible to put a 6 here. It is possible to put a 5 here. But I should think about what this can be. So it's not possible to be a 1. It's not possible to be a 2 by x sum. The sum of these two numbers would need to be 17, and that's not allowed. So it's not possible to be a 1, a 2, a 3. It can't be a 6. It needs to be a 4. It can't be a 5. It needs to be a 4. You need to be a 4. And now the sum of you needs to be 17. This means the sum of you need to be 13. I wouldn't be allowed to use a 1. Well, I just want to see, is it possible for this to contain a 6? If this contained a 6, then I would have 2 numbers that would need to sum to 7. If you contain a 6, then I wouldn't be allowed to use 1 and 2. I could do 3 and 4. That's not allowed. So I don't think it's possible for this to contain a 6. I think I need the 6 up here. I think the 2 needs to go here. Now, what goes down here are the numbers, let's see, 2, 3. Wow, a lot of clarity. A lot of clarity, actually, on what goes down here, I think. I need 1, 2, 3, 4, 5, 6, 7, and 8. I think what's going to happen is if I take 4 plus 2 plus 3 plus 8, I'm going to get 17. Yes, but I need these numbers. There's only one place that a 3 can go, and it's there. You two cannot be 2 and 8. Now I might be able to figure out what goes here. So what are the missing numbers in this region? I'm missing a 1. By the way, that 1 is not allowed to go on the x of the x sum. But I'm also missing, let's see, I've got a 2, a 3, a 4, a 5. I'm missing a 6, a 7, and that's it. I'm missing, I've got these numbers. That means that there's a missing number in this column. In this column, I know where the 1 goes, thereabouts. I know where the 2 goes, 3 goes, 4 goes, 5 goes, 6, 7. This needs to be an 8. This needs to be an 8, and that means that you need to be a 9. No, you're not allowed to be a 9. Now what are the numbers that go here? Well, I need a 4 in one of these two. But what are the numbers that go here? Certainly one of them is a 4. The other ones I'm missing are 6, 7, and 8. 6 and 7. 6 and 7. So this needs to be a 4 now. This needs to be a 6 now. And this needs to be a 7 now. Huh. Crazy. What are the numbers that I'm missing in this row? I'm missing a 1, a 2, and a 6. This needs to be a 1. This needs to be 2 and 6 in some order. But you need to be a 1. I wonder where the 5 needs to go in this region. The 5 isn't allowed to go anywhere. The 5 needs to go here. And now this 5 needs a Dutch neighbor. The Dutch neighbor needs to be a 9. That 9 needs to live below the 5. So what else could I do? I could say something... Oh, is there anything else I could do? I don't know if there is. I need an 8 somewhere in this region. That 8 either goes here or here. 1, 2. I need a 3 somewhere in this region, but I think that 3 can go anywhere. And then I also need a 4 somewhere in this region, and that 4 can only go in one spot. You need to be a 4, you need to be a 3, and now you need to be an 8. And now you need to be an 8, and you need to be a 3. I need some numbers down here. I want to use the x sums, but I don't know what. I need a 2 down here. I also need in this column a 3. But you're not allowed to be a 3, so you need to be a 2, and now you need to be a 3. That's all true. I should think about the fact that either 6 or 7 numbers is going to leave us with 28. I have a feeling that this needs to be a 6. If we were to add the first 7 numbers, what is the minimum sum for 7 numbers? It's 28. The minimum sum for 20 numbers, or for 7 numbers, is 28. It's possible to make that a 7. But if that was the case, then this would need to be an 8 and a 9. And I can't put an 8 or a 9 in this column because of these. So you're not allowed to be a 7. You need to be a 6. Now you're not allowed to be a 7, by the way. Or you're not allowed to be a 6. I need the sum of the first 6 numbers here to be 28. This is 10 and this is 5. That means you two need to sum to be 13. How can we sum to 13? I could use 9 and 4. That wouldn't be allowed because of the 4. I could use 8 and 6. That's not allowed. 13, excuse me. I could use 8 and 5. 8 and 5 is allowed, but I can't use 7 and 6. You need to be 8 and 5, and I can even tell you which one needs to be what. Now you're a 5. You need a Dutch neighbor. That neighbor needs to be a 1. And now you need to be a 7, and you need to be a 1. I'm missing some numbers in this, and now I think these 6 numbers together add to 28. I'm missing some numbers in here. I'm certainly missing a 4. That 4 needs to go there. I'm missing a 6. I'm missing a 7. But we know what goes where. You need to be a 7 like that. And now there's just the numbers in this row and this x sum. If I was able to do this without the x sum, then this would be an extraneous clue. I don't know if that is going to happen for us, but we could see. So what are the numbers that I'm missing in this here row? I'm missing a 1. That 1 needs to go in the center. I'm also missing a 1, 2, 3, 4, 5, 6. I'm missing a 7 and a 9, and there's only one way of doing that. A 7 goes here and a 9 goes here. Now I'm missing some numbers in this column. I'll use the x sum. 1, 2, 3, 4. That 4 needs to go here. And now you need to be a 1, 2, 3, 4, 5, 6. You need to be an 8. Okay, so now you need to be a 2, and you need to be an 8. Missing some numbers in these guys. I'm missing a 2 and a 5. And let's do a little sanity check for ourselves. 4 plus 5 plus 2 plus 1, that is 12. But it's not possible for the 5s to go here. There is indeed a 5 in the column, but something I probably haven't said yet, when you have this Dutch flatmate rule, it's not possible to have a 1 below the 5, so we could determine that anyway. Anyway, you need to be a 5. Now you need to be a 2. You need to be a 6. You need to be a 2. We're missing some last numbers. You need to be a 3, and now you need to be what? You need to be a 6? And we are the 99th person to solve the puzzle. A whole bunch of people have solved it while I solved it. But that was a lot of fun, Flinty. I really like the Dutch flatmate series. I made a video out of the Region Sums puzzle, Dutch Flatmates 4, and that was a 3-star puzzle. I'm not sure I've posted it yet because of the fact that that was a 3-star puzzle and it took me an hour and 40 minutes to solve it. and I just haven't yet brought myself to watch the video yet. But Dutch Flatmates X Sums was tons of fun. I really have to go dig up some more X Sum puzzles. I really enjoyed that one. 99th solver, in it being around for just under 10 hours. I'm pretty happy about that. 42 minutes and 53 seconds. 2, 3, 4, 5. Great. I'll see you next time.